Imagine a software company is contracted to build a national online banking system. The design is finalized, and on paper, the architecture looks perfectly stable. But an unseen flaw can cause the entire structure to collapse without warning. At the start of development, the conditions are usually ideal. The budget is approved, the best developers are hired, and a strict schedule is set. The software project begins exactly as planned. Then, 2 months in, the customer changes major requirements. 2 senior developers resign, and a database server crashes. The original timeline shatters. These are not rare accidents. Every software project faces this exact type of disruption. No matter how meticulously a project is planned, the environment it operates in is inherently unstable. In software engineering, we call these unexpected, highly disruptive future events risks. Writing flawless code is insufficient if the project runs out of money or loses its team. A project's survival demands a systematic preparation for these future failures, and this preparation is called risk management. A risk is the quantified possibility that an unwanted event may happen in the future and negatively affect the project's cost, schedule, or quality. Students and even experienced engineers frequently fail by conflating a risk with a problem. They require 2 entirely different operational responses. A risk is strictly a future possibility. It is something that might happen but has not occurred yet. A problem is an event that has already occurred. It is a present issue that demands immediate resolution. If a customer might change the requirements next month, that is a risk. If the customer has already changed the requirements today, that is a problem. A risk is also distinct from generalized uncertainty. Uncertainty is a situation where the outcome is entirely unknown. A risk is a specific uncertain event with a defined potential impact. Misclassifying a risk as a problem destroys your ability to prepare. You cannot build a contingency plan for a threat you are treating as an already occurring disaster. To apply systematic control to these threats, engineers must first classify them into specific failure domains. The first domain is project risks. These threats attack the internal management constraints of the operation. Common examples include an unexpected budget shortage, a major schedule delay, or critical developers suddenly resigning. The second domain is technical risks. These threaten the engineering stability and architecture of the software itself. This includes database failures, security vulnerabilities, or difficulties integrating an untested framework. For example, if a company mandates the use of a brand new programming language the team has never used before, the probability of a technical risk occurring spikes immediately. Notice the distinction. A server crashing is an engineering failure, while running out of money to buy a server is a resource failure. Separating project and technical risks prevents management errors. It ensures leaders do not try to solve an engineering failure with a scheduling solution. The final domain operates entirely outside the development team's control: business risks. These threats target the external market viability of the software. Even if the technical execution is flawless, business risks can kill the product. This happens if a competitor launches a similar product first, market demand suddenly decreases, or a client withdraws funding halfway through development. For university examinations, rely on the PTB acronym: Project, Technical, and Business Risks. Let's classify common scenarios. A database server crashes during testing. That is a technical risk. The government introduces new privacy regulations, or the company enforces budget cuts. Those are business risks. The delivery of the software is delayed due to intense conflicts within the development team. That is a project risk. Correctly mapping a threat onto this PTB taxonomy is the absolute prerequisite to deploying the correct mitigation strategy. Once we can categorize threats, we need an active mechanism to control them over time. Risk management is not a static business meeting at the start of a project. It is a continuous computational loop that runs alongside development. The loop begins with the identify phase. Finding threats early gives the team the necessary time to arrange defensive backups. Next, the team must analyze the potential impact of those threats and plan specific response strategies to neutralize them. Because the project environment constantly shifts, managers must actively monitor the system for specific trigger conditions. Finally, they review and update the system as the project evolves, completing the IAPMR loop. This system does have limitations. Running this loop is time-consuming, and accurately identifying obscure risks relies heavily on the past experience of project managers. However, faithfully executing the IAPMR loop systematically protects budgets, improves software quality, and secures customer confidence by proving the organization is prepared for adversity. This brings us to a critical interview question. Can a software project ever be engineered to be completely risk-free? The answer is mathematically and practically no. Every software project involves uncertainty. The true objective of the discipline is not elimination. The goal is to minimize the probability of an event occurring and to minimize its impact if it does strike. To achieve this, remember the rules. A risk is a future uncertainty. A problem is a present reality. You must accurately map all threats through the PTB framework, differentiating between project, technical, and business risks. And you must execute the IAPMR loop continuously to keep those identified threats suppressed. In our next phase, we will translate these abstract concepts into formal mathematical tools, constructing a risk register and plotting threats on a probability impact matrix. In the world of software engineering, unpredictable events are guaranteed, but with rigorous risk management, absolute project failure is not.